All right, guys, this video is going to be all about similar triangles and indirect measurement. Let's take a look at this problem. It says in the diagram below, triangle GHI is similar to triangle JFI. Find K. All right, so they're asking us to find K, which is right here. That's this side length. And from seeing you guys working in class, I know sometimes you guys like to replace these variables just with an x because that's what we're used to for equations. So we could do that right here. We can use x in place of k. And then basically we want to write out a proportional equation. Okay, so I think what I'm going to show you guys for this problem is I'm going to show you within figure ratios for this one. Okay, so my very first fraction is going to be the two values. I should get rid of this highlight that's on the K right here. The two values from the triangle on the bottom, okay? And I'm just going to talk myself through it. I'm going to do x over 4, and the x is like the height of the triangle, and the 4 is the base. So I'm doing height over base. Then I'm going to come up to this triangle up here. These are the two sides that I'm going to use. And I'm going to do the same thing. If I did x over 4, height over base, I need to do height over base. So I'm going to do 6 over 8. Okay, and then you guys know that we can cross multiply. So we're going to multiply the 4 times the 6, and we're going to get 24. And then we're going to divide by 8. 24 divided by 8 is equal to 3. Okay, just for this one, I'll put all of that up here. So we're doing 4 times 6, which gives us 24. And then we divide that by 8. So we multiply the two numbers that are across from each other and then divide by the third number in the equation. And that is how we're getting an answer of 3. 24 divided by 8 is 3. Okay, I'm going to go ahead and submit, and we'll do another one. Okay, so this is perfect. This is the other type of configuration. These problems have two triangles where we're trying to find two similar triangles where we're trying to find a missing side. The big difference here is that these triangles are attached in some way. So the first one, they were attached like at the vertex, and this one they're kind of set inside of one another. And really what I like to do for these problems is I like to go over on the side and do a quick sketch of the two triangles. Okay, so my first triangle is this triangle right here, this guy right here. Okay, so the base of that triangle is 3 and the height is 4. And then my other triangle is this triangle that basically encompasses this whole thing, the large triangle on the outside. So the height of that triangle is 8 and the base is S. This is what we're trying to find. Okay, so coming over here, I'm going to put an 8 for the height, and then we can just use X, or you could use S. Any letter would be fine for the base right here. And I'm going to do the same thing that I did before. I'm going to do within figure ratios because this is something new that we're talking about, but you guys could use anything for this. You could use scale factors, certainly for this problem. You could use between figure ratios, okay? So within figure ratio, for my first fraction, I'm taking both of the numbers from the same triangle. And I'm talking out loud to myself and saying what I'm doing. So I'm going to do base over height. I'm going to do 3 over 4 equals base over height. Base over height. Okay, and then we're going to cross multiply. We're going to do 3 times 8 divided by 4. I think we actually end up with, I don't remember what the answer to the first one was, but this seems very similar to that one. So 3 times 8 gives us 24, and then 24 divided by 4 is equal to 6. Seems like the same numbers. Maybe they're a little different. Okay, I'm going to do one more, and then maybe that'll be it for this video. So let's do the same thing here. We have two triangles that are set inside of one another. I'm going to do a little sketch on the side and draw them out. This really helps me set up my equations. It makes it so much easier. So for the little triangle, we have a height of 16 and a base of 30. So we've got 16 and we've got 30, right? For the height of the big triangle, that's what this number here represents. We've got 32, and then the base, that's our variable. So we'll do 32. Ooh, for this one, you could do scale factor. For sure, that would definitely work. Okay, so I'm noticing scale factor, so I'll just say it out loud to you guys. I mean, I'm noticing right off the bat that 16 times 2 is 32. So this big triangle is twice as big as the little triangle. So this has to be 60 right here. This has to be 30 times 2, which is 60. But I'll show you the equation method as well. I'm going to do, I think I was doing base over height for all of these. I'll just keep going with that. I'll do base over height. We'll see if I'm right. We'll see if the answer is 60. Base over height equals base over height multiply the numbers that are across from each other. So 32 times 30, and then divide by the other number, which is 16. Let me grab a calculator real quick here. Pull it over on the side. So 30 times 32 is 960. Divided by 16 is, look at that, it's 60. Okay, hit submit on that one. All right, and then all of the other problems kind of go in the same way. You know, let me see if I can, I'm going to try to find, I think there's some problems at the end that I want to show you guys. So let me grab one of those. We'll do one more and then we'll stop the video. So here's a really good example. I forgot that there were word problems. And so for this one, I definitely think drawing a picture is the way to go. A shadow 4 yards long is cast by a street lamp that is 3 yards tall. What is the length of the shadow cast by a nearby ash tree that is 9 yards tall? So we've got a street lamp that's 3 yards tall. So I don't know what a street lamp looks like, but maybe it looks like, I don't even know. Does it have like light bulbs coming off of the top like this, shining some light? Okay, so that's our street lamp. I know that's a terrible drawing. And then it has a shadow as well. So there's the street lamp, and then there's the shadow that it's casting. Our street lamp is 3 yards tall, and the shadow is going along the ground for 4 yards. Then we've got a tree. I think I can draw a tree. I don't know if this is what an ash tree looks like, but I've got a tree here. Okay, and they're saying that the tree is 9 yards tall. So I'm actually going to draw, like, we know that all of the problems in this lesson are related to triangles. So that's really what they're doing here. They're taking these tall figures like a street lamp or a tree, and those are like the heights of the triangles. And then the shadows are the bases of the triangles. So I drew a tree so we know what we're doing, but I'm also going to draw that line right there. All right, so let's see. What is the length of the shadow cast by a nearby ash tree that is 9 yards tall? So the tree is 9 tall, and they're asking us to find the shadow. Okay, and do you guys see that these are triangles? Look at this. These are just triangles. Okay, so now we can do our equation. I'll put it up here. I'm going to do base over height equals base over height. Base over height. You could also use scale factor for this one, equals base over height. Do 4 times 9 and then divide by 3. 4 times 9, multiply those numbers that are across from each other and divide by 3, and we get 12. Okay, and that makes sense. That seems reasonable that the shadow would be 12. Okay, that's it. I think this is the last one that I'm going to show you guys. All right, good luck everyone. Let me know if you guys have any questions.